Today, we want to talk about solving triangles again. If you recall, way back in the beginning, we learned to solve right triangles. So the three pieces of information that you're given to solve a triangle, remember, I have to give you three, you have to find the other three. Of those three pieces of information that I give you, one of those pieces of information has to be a right angle. Once we're solving right triangles, we have the following tools. First, the sum of the angles in a triangle is 180 degrees. Or pi radians, if you want to solve your triangles in radians. Because we're dealing with right triangles, one of the things that we get to use is the Pythagorean theorem. The other piece of information, the other tool that we have are the trig ratios. The sum of the angles, that's all about the angles. The Pythagorean theorem is all about the sides. The relationship between the angles and the sides comes from our trig functions, our trig ratios. So sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. And tangent of theta is opposite over adjacent. For sine and cosine, they use the word hypotenuse, so that tells you that you have to be dealing with a right triangle. Tangent of theta is opposite over adjacent. Since we're saying things like opposite over adjacent, the third side is implied to be hypotenuse. So we don't get to use tangent of theta is opposite over adjacent, except in a right, except in a right triangle. The Pythagorean theorem says that adjacent squared plus the opposite squared is the hypotenuse squared. Normally we say a squared plus b squared equals c squared, because c is a great word, great abbreviation for hypotenuse, because the letter c appears in the word hypotenuse so much. So I think the reasoning is more like, it's like using the letter M for slope, because that makes sense, because M appears so many times in the word slope. So the sum of the angles is 180 degrees. That applies to every triangle, but the Pythagorean theorem and these trig ratios only apply in right triangles. So sum of the angles, this is for any triangle. But these other two are only for right triangles. So if we want to solve oblique triangles, that is a triangle that is not a right triangle, then we need a different set of tools. We don't get to use Pythagorean theorem or trig ratios. At least we got the sum of the angles. So if we want to solve some oblique triangles, that is non-right triangles, we need some different tools. One of the tools we have for solving oblique triangles is some of the angles is 180 degrees, because we always get that one. That applies to all triangles. We don't get to use the Pythagorean theorem anymore. Sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. No right angle, no hypotenuse. You don't get to use the Pythagorean theorem. If we don't have a right angle, then we don't have a hypotenuse. No trig ratios, no Pythagorean theorem. What we're going to do is upgrade our Pythagorean theorem to the law of cosines. I'm about to change pages because of the exciting news. So the law of cosine is like a better version, a more general version of the Pythagorean theorem. Here's the setup we're going to use. So here's how we're going to set up our generic triangle. Before, we had C, the hypotenuse, because we had a right angle where I've written gamma. So I'm going to have angle alpha opposite side A, angle beta opposite side B, and angle gamma opposite side C. This will be our generic triangle. This will be our naming convention. A and alpha are an opposite pair. B and beta, opposite pair. C and gamma are opposite pair. The law of cosines is going to be a relationship between the side and the angle. You don't get to use the Pythagorean theorem. So let's write down the first version of the law of cosines. In my notes, it says pause for dramatic effect. This is where you're supposed to say, dude, is this not the Pythagorean theorem that we said we're not supposed to use? It's like, well, hang on, we're not done yet. But that's what we're going to notice. We're going to notice that the law of cosines, we start off by writing the Pythagorean theorem. C squared is equal to A squared plus B squared. But then we're going to have an extra term. This is the extra term, minus 2 AB times the cosine of gamma. So the law of cosines looks like the Pythagorean theorem, but with this extra term. minus 2ab cosine of gamma. Note that if we have a right angle, if gamma is 90 degrees, then we'll be able to call C the hypotenuse. And if gamma is 90 degrees, the cosine of 90 is equal to 0. And so this term will drop out. If gamma is equal to 90 degrees, then cosine of 90 is equal to 0. So we're not subtracting 2ab, we're subtracting 0, and this becomes the Pythagorean theorem. So note. If gamma is equal to 90 degrees, then C is the hypotenuse. And also note that cosine of gamma is equal to 0. So we get C squared is equal to A squared plus B squared. So the Pythagorean theorem is just a special case of the law of cosine. So we can think of the Pythagorean theorem as a special case of the law of cosines. Now, this particular version only uses the gamma. What about the alpha and the beta? Well, we have multiple versions of the law of cosine. 3, in fact. This is the C and gamma version of the law of cosines. But there's one where we just shift everything over. So we can there's also a law of cosines where we have B squared is A squared plus C squared minus 2AC times the cosine of beta. So here's another version of the law of cosine expressed with B and beta. There's another version of the law of cosines with A and alpha. Strictly speaking, we don't need all these different versions. All we're doing is switching the names around. Notice the ones on the outside is the opposite pair, C and gamma, B and beta, A and alpha. So the opposing pair sits on the outside of your law of cosines. It's starting to bug me that these aren't in parentheses. So we can use the law of cosines to figure out one piece of our opposing pair. Notice that there's three versions for each of the three opposing pairs. So C and gamma, B and beta, A and alpha. What we're going to use the law of cosines for is to find out the side opposite a known angle or an angle opposite a known side. That's what we're going to use this law of cosines for in those two cases. A side opposite a given angle or an angle opposite a given side. That's when we can use the law of cosines. So we're going to use the law of cosines to find this side, A, B, or C, depending on whether we have alpha, beta, or gamma. Technically, we can use this A and alpha to find the side B, but it ends up being a quadratic equation and no one wants to do that. No one has ever, in my history teaching trigonometry, volunteered to make the quadratic equation solve for B. So don't start now. There's a couple of ways that I think about how we approach this problem. We're going to use the law of cosines when I have what I refer to as like a complete set of information, a full alphabet. If I have angle alpha, side B, and side C, that's an A thing, a B thing, and a C thing. That's a full set. I got a whole alphabet. I don't have an opposing pair. If I have side A, side B, and side C, that's a full set. I don't have an opposing pair. You can use the law of cosines when you don't have an opposing pair. And you want a piece out of an opposing pair. A variation on saying this is when you are lacking an opposing pair. So you have A, but not alpha, have B, but not beta, have C, but not gamma. Notice in my full alphabet, our full set of info, I've got an A thing, a B thing, and a C thing. A, B, C, alpha, B, C, A, beta, and C, A, B, and gamma. Yeah. An opposing pair would be you should have A, but you don't have alpha. So what I mean by opposing pair is you have A, but you don't have alpha. Right? You have A, but you don't have alpha. Or if you have B, but don't have beta. That's the same thing. Three. No, law of science is for when you don't have an opposing pair. Oh, sorry. Law of cosines is for when you don't have an opposing pair. Here are the 4 cases where you get to use the law of cosines. Notice that in these 4 cases, I've got an A thing, a B thing, and a C thing. I don't have an opposing pair. I don't have A and alpha. I don't have B and beta. I don't have C and gamma. There's another way. The traditional way we identify the law of cosine is to say we have the SSS case, or when you have 3 sides. So this A, B, and C. The law of cosines is for the SSS case, when you have all 3 sides. These other 3 cases where you use the law of cosines, those are called the SAS case. Side, angle, side, for 2 sides and the included angle. These 3 are the SAS case. 2 sides and the included angle. Now, these are the 3 different ways that I think about using the law of cosine. It boils down to this. Use the law of cosines if you have to. When we're first learning this, I've had all 3 of these explanations kind of work for different students. That's why I got to put all of them out there. I described the SSS case and the SAS case as a full set, a full alphabet, an A thing, a B thing, and a C thing. Sometimes it works when you think about lacking an opposing pair. A and alpha don't have that. B without beta, C without gamma, or the other way around. Gamma without C, beta without B, alpha without A. And some students like it when we talk about SSS case. That's the easy one to identify. You just have 3 sides. Or the SAS case, when you have 2 sides and the included angle. Notice that side A and B have gamma included in them. Gamma is made up of the sides A and B. Sides A and C form the angle beta. So beta is included in sides A and C. And angle alpha is included in sides B and C. So 2 sides and the included angle. The angle is always named for the side opposite, so the side that's not touching it. So A and alpha, B and beta, C and gamma are opposite pairs. We would not use the law of cosines. If we had side C, side A, and angle gamma, that doesn't fit law of cosines. But if we go back to the overall rule, use the law of cosines if you have to. We can't use the law of cosines if we have C, A, and gamma, because if I have gamma here then C goes here, and A goes here. I've got B in these two places. That's a quadratic in B with irrational coefficients. We don't want to do that. So we're like, oh, yeah, but nah. Use the law of sines, which we haven't got to yet. Cosine and sine aren't equal. They're co-functions, and so co-functions of complementary angles are equal. So cosine of 30 is equal to sine of 60. That's one way they're related. They're also related through a Pythagorean identity, sine squared plus cosine squared equals 1. That's not quite helpful in solving triangles. Let's do an example. Let's suppose that we have side A is equal to 12 centimeters and angle beta is equal to 37 degrees and side C is equal to 18 centimeters. Beta. So we've got to analyze what case we are in. It's probably a law of cosines because I haven't even talked about law of sines yet. So that's probably not going to be it. That would be kind of a jerk move on my part to say at the first example just be a law of sines example. I haven't even talked about it yet. So here we go. We've got to think about what we can use. And we don't want to just think, well, it's got to be law of cosines because that's what we just talked about. So that's what the example is going to be. We got to think about why that's going to be this thing. We have side A and side C. Angle beta is included in sides A and C. So I have two sides and the included angle. That's what we might notice. We also might notice that I've got an A thing, a B thing, and a C thing. B thing represented by the angle beta. So that's that full alphabet of information. That's the law of cosine. Also notice I have A but not alpha. I have beta but not B. And I have C but not gamma. So I'm lacking an opposing pair. Here's the other thing that we notice. We've only got one angle. Beta is 37 degrees. And I don't know B. If you've got one angle and you don't know the side opposite that angle, that's the next thing you should get. I'm going to write down the law of cosines that uses angle beta. So this is what's telling me my first step. We have beta. We have one angle, beta, but not B. So I'm going to use the law of cosines. I'm going to write down the law of cosines that has the beta in it. So B squared is equal to A squared plus C squared minus 2AC times the cosine of angle beta. So we're going to plug in the things that we know. A, C, and beta. And then we're just going to use our calculating machine. This is when we're going to be really sad if we left our TI-84 at home and have to do this on our phone calculator. TI-84 is great because we can type this whole thing in all at once. I want 12 squared plus 18 squared minus 2 times 12 times 18 times the cosine of 37 degrees. Close the cosine, close the square roots. There's our side B. What we want to note is that given this information, side B was the only thing that we had an option to get. That was the only thing we could have gone for. With this information, we had but one choice. We must take the ring to Mordor and throw it into the fires of Mount Doom. You know you're cool when you can get away with saying shit like you have but one choice. Point of order, that means we do not have a choice. Hugo Weavers can get away with that. He's on my list of guest speakers for this class. And I'm going to make sure it's this. So I was like, oh, with this information, you have but one choice. You use the law of cosine to find side B. This is the only thing that we could have done. Find side B. Any questions? All right. Let's look at a different scenario. Let's suppose that I told you that side A was equal to 7 inches. Let's say side B is equal to 5 inches, and side C is equal to let's see, can't be more than 12. So let's go with 10 inches. This one is much easier. It's the side case, and that says to use the law of cosine. Here, we have but 3 choices. I could use the a squared one to find alpha. I could use the b squared one to find beta. I could use the c squared one to find gamma. We need to use the law of cosines. We don't have a choice there, but we can use, because we lack an opposing pair that we're going to need in the law of sines. But we can use the law of cosines to find alpha or beta or gamma. We just have to pick one to find. So let's see how we can use the law of cosines to find an angle. Let's say that a squared is b squared and c squared minus 2bc cosine of alpha. I want to use this to solve for the alpha. So we've got to turn this around to solve for alpha. We're going to solve this equation for the alpha. So that means get rid of any terms that don't have alpha in them. So I'm going to subtract the b squared and the c squared from both sides. So I'll subtract b squared and I'll subtract c squared from both sides of the equation. Seeing in the order of operations of things that happen to alpha, first we did the cosine, then we multiplied by negative 2bc, then we added b squared and c squared. So the first thing we'll undo is the b squared and c squared by subtracting b squared and c squared from both sides. Then we will divide by the negative 2bc. Then we will go look at that fraction and say, this looks terrible dividing by negative 2bc. That looks awful. I've got a squared minus b squared minus c squared over negative 2bc. No, that looks terrible. So we're going to rewrite this side to make it look nice. Specifically, what we don't like is dividing by the negative 2bc, having one term in the denominator with a negative sign in it. I don't know if I've successfully trained you to not like that, but you're supposed to look at this and say, ew, dividing by a monomial with a negative coefficient, ew. Everybody look at this and say, ew, ew. I need to hear it. I'm trying to build prejudice here. I'm trying to, actually, if you like it, if you're like, oh, no, I like that negative in the denominator. Weirdo. But I do want you to see what happens, what we generally try to do. Even math has its beauty standards. Let's just put it that way. Even math has its beauty standards. And so you might see this expressed differently. What I'm going to do is I'm going to change all the signs just for prettiness sake. I'm going to make the b squared and the c squared positive, the a squared negative. Change all the signs. Everybody see what I did there? I just changed all the signs. And then I don't like leading with negative. So we put the negative at the end. This is like that toxic positivity culture. It's like, oh, just kind of like accentuate the positive. Eliminate the negative. You can't just eliminate the negative, Frank. I mean, the negative is just a fact of life. Yeah. Multiplying top and bottom by -1. And then what we're going to do is we're going to rewrite this. So it says b squared plus c squared minus a squared all over 2bc. This is just us adhering to some typical math beauty standards. Then we just need to do the cosine inverse. And I'm going to write it on single line syntax because we're going to be punching this into a calculator. We're going to be entering this into our calculator. So from here, after I clean this up to get rid of the negative in the denominator, make these positives and this one negative, I'm going to just do a cosine inverse of both sides. No, we took the cosine inverse of both sides. We didn't multiply. We performed a cosine inverse on both. So we can find alpha by doing the cosine inverse of the numerator is going to be b squared plus c squared. So 5 squared plus 10 squared minus a squared, 7 squared, close parentheses divided by open parentheses 2 times 5 times 10. Close parentheses, close the cosine inverse. Now this seems like it's going to take way too long. At this point, it might be worth hiring somebody, but we're not going to do that because this can go much faster. Let's say we wanted to use this to find beta. We had the option of finding alpha, finding beta, or finding gamma. So if we're finding alpha, that's the square that we're subtracting. And then the other two are the ones that aren't getting subtracted. So if I wanted to find beta, I would just do a cosine inverse of, instead of 5, 10 being the positive ones, I would use 7 and 10. So 7 squared plus 10 squared minus 5 squared divided by 2 times 7 times 10. So beta is going to be cosine inverse of 5 squared is going to be 5 is going to be the negative one. So it'll be 7 squared, 10 squared minus 5 squared, close the top, divided by open the bottom, 2 times 7 times 10. Close the denominator, close the cosine inverse. So if we remember the structure of using the law of cosines to find an angle or a side, then it goes much quicker. If I swap the 5, move the 5 and the 10, that will give us gamma. So there we are using the law of cosines to find it. You don't have to memorize the formulas for the law of cosines, you just have to remember them. It's based on the Pythagorean theorem. And then getting the one for the angles is a matter of rearranging it to figure out what the angle is. All right, let's pause, come back and learn about the law of sines.